In the last video, we come across with what are the various terminology we'll come across in projection. We did. In this video, we are going to know what is the classification of projections. In this video, classification of projections is nothing but what are the different types of projections are going to be present in drawing. We are going to discuss in this. So in the previous one itself I said projections. Here I gave few. One is a multi-view projection, oblique, isometric, perspective. What are the characters of them? When we are going to get one particular type of projection, we'll discuss in this particular video. Before that, you should be aware of some basic terminology, whatever it is mentioned here. That is projector. It is considered as a source of light or observer. Source of light or observer is going to be considered as projector, and projector is a source of light or observer. Second one is projectors. The rays which is emitting from the source of light is called projectors, or the observer what he is looking. Whenever the light is there, then only he can able to observe it. Those rays are also called projectors. Next one is projection. The shadow, whatever the image you are drawing, that is considered as projection. It is a actual drawing what you are making. Next one is principal plane. Principal plane is nothing but a surface or a plane which is present in the path of a projectors, means rays, shadow rays. In the path of the shadow rays, whatever we are placing, it is considered as a principal plane. It is also called obstruction to the rays. So apart from these, we are already come across the size of the projection. We will get it as a same with respect to the position of the principal plane whenever the rays are parallel. It is called parallel line projection. In order to get this, the observer should be at infinite distance. But if you consider, if the observer is at finite distance, the rays are going to be diverging in nature. Here the size of the object will be changes, or the size of the projection will be changes depending upon the position of the principal plane. Whenever it is moving away from the observer, the size will be increases. The size is going to be increases. What it is, whenever the principal plane is moving away from the observer, the size of the projection will be increases. So here diverging line projection and parallel line projection only we are aware of it. In this, some other division is also there that we will learn. So in order to know that, I am going to consider this particular terminology. What all are they? Observer or source of light, I am going to mention in the next slides as the eye of a observer, or some books they mention it as a bulb. They show it as a bulb, but in my explanation I was considered source of light or observer with the eye of the observer. So the projectors, this is nothing but rays. Parallel projectors I was represented like this, and diverging projectors is diverging like this. Next one is a principal plane. The principal plane is represented as a straight line. Why I was mentioned it as a straight line means, so if you consider it is a plane, in one view it is a plane, but in this view it appears as a line. The principal plane I am showing in side view, so it is going to represent as a line. The principal plane in my classification I was represent as a straight line. And then object, three-dimensional object I was considered whatever it is. So I was, for your explanation, I am taking some box for consider it as a object. Object I was consider it as a block. Now in these, what is the classification of it? So for your clarity, I'm having the classification chart in the beginning itself. What is this classification chart if you consider? So I hope this one is visible to you, all of you. So I will hide myself whenever I am explaining that particular topic. Now let us consider the projections. The projections are divided into two broad classifications based on or with respect to the source position. This is also called observer's position. So here we can able to classify the projections based on few elements. One is observer's position, another one is principal plane with respect to projectors, another one is object nature. So all those things you can able to learn here. So first one is with respect to the source position. Source is nothing but observer. If the observer is at infinite distance, then it is called parallel line projection. Why? Once the observer is at infinite distance, the projectors are going to be parallel to each other. The best example we can able to consider as sun rays. Why you are consider sun rays as the example? So the sun is very far from the earth. Once if they are going to travel for lakhs of kilometers, the diverging angle will be almost negligible. That is why we are going to consider sun rays are approximately parallel lines. Okay, now so whenever the observer is at infinite distance, the projectors are going to be parallel to each other. That's why the shadow, whatever we are obtained, whatever we are going to get by falling of the parallel rays. Let us consider these are the rays. So these are the different lines. These are the rays I am assuming. These are parallel to each other. Once if they are parallel to each other, the shadow is obtained because of these parallel lines. Then it is considered as parallel line projection. Then it will be considered as parallel line projection. Good. Now if the projectors are not parallel, sir, so that is if the observer is at finite distance, just like an example of human eye, whatever we are observing, finite elements only we can able to observe, or we can able to consider the best example as camera, lens of a camera. Whatever our human eye, whatever they are observing, the objects are going to be at finite distance, and the rays are going to be, if it is a human eye, the rays are going to be converging. But if you consider the in opposite direction, it is a diverging. So similarly, if you consider it as a camera, so from here light is passing through like this. Whenever this light will fall on the object, then only we can able to capture the picture. So the best example is camera or human eye, or we can able to take it as a example of cinema. Cinema is also example for this. Or nowadays in the majority of the seminars we are going to observe projector. That is also example of it. So here the rays are going to be diverging. So this particular, whenever the observer is at finite distance, then the corresponding projection is called diverging line projection. The example of diverging line projection is a perspective projection. This is nothing but however it appears to the human eye. If you draw as it is, that is considered as perspective projection. Here also in perspective projection there are different types are there. What all are they? The methods of drawing are going to be two types. One is visual ray method. I will erase again. Just I will draw it on the next page just for your clarity. Perspective. The perspective projection, again we are divided into perspective projection. The objects in perspective projection can be drawn with the help of two methods. What all are those two methods? First one is visual ray method. Visual ray method. Another one is vanishing point method. Vanishing point method. It is not vanishing method, it is a vanishing point method. So in vanishing point method, again there are three types are there. There are three types of vanishing point methods are there. One is single point vanishing method or one vanishing point method. Second one is double vanishing point method. Third one is triple vanishing point method. Triple vanishing point method. These are the all these things in detail we will learn whenever we are entered into the vanishing point, perspective projection. So perspective projection, the objects can be drawn by using either visual ray method or vanishing point method. In vanishing point method itself, depending upon the object complexity, we may use single vanishing point method, double vanishing point method and triple vanishing point method. Now apart from this, we are going to consider, now we will move on to, so that is related to the diverging line projection. That is related to the diverging line. Example is a perspective. In perspective there are two ways to draw an object. One is visual ray method, another one is vanishing point method. In vanishing again three types are there. But now we will move on to the parallel line projection. Parallel line projection. So parallel line projection means observer is at infinity distance. Observer is at infinite distance. The ray, then automatically the rays are going to be parallel. Now here if you observe, all these lines are parallel. So for your clarity, I am assuming these are projectors. These are projectors, or otherwise you may assume my fingers are going to be projectors. Assume all these are parallel to each other. All these are parallel to each other. Now with respect to the, what is the next classification, sir? It is with respect to the principal plane. What is that? Principal plane. So based on the principal plane, we are divided this parallel line projection into two broad classifications. Two broad classifications. What all are those two classifications, sir? So these are the projectors. These are the projectors, but side view we are going to get like this. The lines we are going to get like this. And assume this is a principal plane. So if the principal plane is perpendicular to the projectors, if all these rays are perpendicular to this principal plane, then it is called orthographic projection. What is the condition? If the rays are perpendicular to the principal plane, then it is called orthographic projection. What is the another one, sir? If the rays are like this, the plane is not like this. If the plane is inclined, so here if you observe, this angle is not 90, it is other than 90. So if the angle between projectors and principal plane is other than 90 degrees, then it is considered as oblique projection. So can you able to have the idea now? So what is that? Depending upon the angle between projectors and principal plane, they are divided into two broad classifications. What all are they? If they are, the projectors and principal plane are perpendicular to each other, then it is considered as orthographic projection. Orthographic projection. If they are other than 90 degrees, then it is considered as oblique projection. Sir, can you able to give an example to have a better idea of it? Yes. So at the 12 noon, sun is exactly at the top of the earth. The rays are going to be perpendicular to the ground. Therefore, this is a orthographic projection. Sir, what about from sun rises to 12 noon? and 12 noon to sunset, sun is here, the rays are not perpendicular, they are inclined. So this inclination goes on, increases, comes to 90, again reduces, comes to 0. So whenever we are considering, let us consider, if it is a earth, you assume it as a principal plane. If a sun is at the 12 noon, the rays are perpendicular to the principal plane. The rays are perpendicular to the principal plane. Now if the sun rises, then the rays are parallel to each other. Now this angle is not 90 degrees. If sun is going to be here, some particular angle, then also the rays are parallel to each other, but the angle is other than 90. Even if the sun from 12 noon to sunset it is taking place, here also the rays are parallel to each other and the angle is not equal to 90 degrees. So except first situation, remaining three are considered as oblique projection. Oblique projection. I hope this you got the clarity. When the angle between projectors, means rays, and principal plane are perpendicular 90 degrees, then it is called orthographic projection. Ortho is nothing but 90. Orthographic projection. So if the angle between them is other than 90 degrees, if it is not equal to 90 degrees, then it is considered as oblique projection. Here if also you observe, this is the principal plane, this is the projector, the angle theta is not equal to 90. So it is considered as oblique projection. Sir, in oblique projection, how many types are there? So the angle may be varies from 1 degree, 2 degrees, 1.84 degrees, 33.87 degrees, like this. So many angles are there. But among these, popular oblique projections are only two. Popular and oblique projections are only two. What all are they? They are I was mentioned here, one is Cavalier projection, another one is cabinet projection. Cavalier projection and cabinet projection. Sir, what is the difference between these two? What is the difference between Cavalier projection and cabinet projection? So the difference is, even this one you can able to observe in a real world also. So whenever sun rays taking place, whenever the sun is going to rises, so just take an example here. So in this case, let us consider, we are considering this is the plane, and here there is a building or some tree is there. There is a building or otherwise I am assuming it is a building. Whenever the sun is going to be here, then what will happen? The shadow of this building is going to be this much, very huge, sir. Now if the sun is reaching to this particular position, the building shadow is going to be reduced. I am not actually, this is going to be this much size. If I write here, it is going to be overlaps. Okay, the size is this. Now once the sun is going to be here, this is going to be reduced. Once the sun is going to comes to this position perpendicular, this is going to appear as a plane only. Here only it will fall. Now here the depth of the object will be changes, but this height is not, this shadow width is not going to be changes. Once if you observe, the building width won't be changes, how much shadow depth is going to happen, that will be changes. Am I right on it? So once if you observe, the sun is going to be from rising to mid, so width of the building, the shadow width of the building won't changes, but length of the shadow will be changes. That is only the thing what we considered in this particular Cavalier projection and cabinet projection. What it is, sir? Now once if you observe, here two things I was mentioned. Unfortunately they gave it as a different values. So here Cavalier projection and cabinet projection. What is the difference between these two? So So here, let us consider in Cavalier and cabinet the length. Let us consider the object length. So here, whatever I am writing with capital letters, they are object information. They are related to the object information. Object length is capital L, breadth is capital B, depth is capital D. Then in Cavalier projection, what will happen? Here small l is equal to capital L, and here I am going to consider instead of B I will consider H, length and height. This is going to be height. So small h is equal to capital H. Here also actually this one is appears more than this, but in the diagram while copied it, there is a problem. But here also length is equal to capital L, height is equal to capital H. Only the difference is in case of Cavalier projection, the depth in Cavalier projection should be equal to actual depth of the object, whereas in cabinet projection the depth of the shadow or projection is equal to half of the depth of a object. Good. So the front shape won't have any difference whether it is a Cavalier projection or cabinet projection. The front shape, however it appears, it is going to be the same, but only the depth, how much depth it is going to appears, then there is a difference. If the actual depth you are taking, then it is considered as Cavalier projection. Only half of the depth if you are considering, then it is considered as a cabinet projection. Cabinet projection. Where we will use this, sir? Let us consider there is a godown. There is a godown, sir, or otherwise rail you may consider. The length is huge as compared with width and height of the train. The length of the train is huge. So in order to fit that into a drawing sheet, better to go ahead with cabinet projection. We can able to reduce the depth or length of that particular train. No sir, if it is simply like a box, here length, height, breadth, all these are almost more or less equal to each other, or very small variation will be there. In such cases we'll use Cavalier projection. If the depth of the object is huge and there is no much significant information is present, in depth, we'll go ahead with cabinet projection. But length, breadth, height and depth, whatever it may be, are going to be more or less equal or nearer to them, then we are going to use Cavalier projection. Good sir. What is the condition? So you said it depends on theta when it is going to happen, in which situation we will get Cavalier projection, when we are going to get cabinet projection. Here whenever theta is equal to 45 degrees we will get Cavalier projection. What is the meaning of it here, sir? Principal plane and projectors, angle between them is going to be 45 degrees, then we are going to get Cavalier projection. What about cabinet projection, sir? When theta is equal to 63.4 degrees we are going to get cabinet projection. Same thing I was mentioned here, just you have a look into it. Okay sir, we will accept it, whatever you said we will follow. But what is the logic behind it? How can we get, what is the relation between capital D to the small d? Capital D to the small d, we have the equation. What is that equation, sir? Very simple. Small d is equal to, all of you remember this is important for you. Small d is equal to capital D into cot theta. Capital D into cot theta. Sir, we are not familiar with cot, we will be familiar with tan. Okay, convert it. That is equal to D divided by tan theta. Sir, for Cavalier projection, in order to get capital D is equal to small d, denominator should be 1, that is tan theta should be equal to 1. For which angle theta is for 1? For theta is equal to 45, it is going to be tan 45 is 1. Therefore, whenever theta is equal to 45, we will get Cavalier projection. What about this, sir? Very simple. When theta is equal to tan theta is equal to 2. Why? Because here small d is equal to capital D divided by 2. Denominator is 2. Therefore, theta should be 2. Therefore, what is theta, sir? Theta is equal to tan inverse 2. What is the tan inverse 2? Just you calculate with the calculator, we can able to check it out. So shift to tan inverse 2. So this value, oh my god, it is not going to be that much visible. Tan inverse 2. If I make it as equal to, so what is the value I am going to get? 63.4349. 4349. That's why we are going to consider 63.4 degrees for the cabinet projection. So these two are important, and how we got also I gave it here. So okay, in orthographic projection, now again we will come for orthographic. When the rays are perpendicular to the principal plane, then it is called orthographic projection. Why it is called graphics? Because our subject is engineering graphics. In graphics, majority of the area is going to covers with these. Some people may ask, sir, perspective projection also we studied in graphics. Yes, but for so many years, mostly this isometric and multi-view projection only will come across. That's why it is going to be considered as orthographic projection or ortho projection. Okay. Now here, you said 2. What all are these two, sir? Depending upon, sir, let us consider. Principal plane should be like this, projectors are perpendicular to this. Depending upon the object orientation, we are going to get, in order to get the complete information of an object, in which way you are getting the complete information. Again, the elements are divided into two broad classifications. What they are? Let us consider this object is having length, height and breadth. So in order to get this information, if I view from here, I am going to get length and height. Okay. No, sir, if you are going to view from here, for your clarity, I am rotating like this. If you are going to view from here, I know length and breadth. Sir, if I view from here, I can able to get breadth and height. In order to get the complete information of an object, observer is changing his position. So here once he observed from here, another time he is observed from here, in another case he is observed from here. If the observer is changing his position to get the complete information of an object, it is called multi-view projection. What it is? Just no name itself it is saying. I am viewing from here, I am getting the diagram. I am viewing from here, I am getting the diagram. I am viewing from here, I am getting the diagram. So in order to get the complete information, the observer is changing his position. Then it is called multi-view. Means different views, different places he is there and he is getting the different shadows. Shadow is nothing but a view. So he is going to get different shadows to get it. So that's why it is considered as a multi-view projection. That is why in the last video I said, once if you observe this particular object, so it is a rectangle. All of you observe, this is a rectangle, sir. Height and length is appears in the front view. Sir, if I view from top, length and breadth I am going to get same diagram I was mentioned. As an engineer only can able to know that is a solid. So that is considered as multi-view projection. So okay, multi-view projection I will explain again in detail. Now we will move on to the sir, I can't able to change my position. I am an observer. I won't change my position. Then how to get a complete information? why you are struggling to change your position? Change the orientation of the object. Now you observe. You know only length and height. Just I am tilting like this. Tilting like this. You know length, breadth, height. All this information I am getting. I am going to rotate like this. So here all the information you are getting by changing the orientation of the object. So in order to get the complete information, if the observer is changing his position, if the observer is changes his position, then it is called multi-view projection. If the observer changes its position, then it is called multi-view projection. If the object changes its position, it is called axonometric projection. I have a doubt why it is called axonometric projection, sir. Let us consider. Let us all of you observe. So here, this is the length, sir. This is the height. This is the breadth. Now once if you tilt it, this is the length axis, and this is the height axis, and this is the breadth axis. Are you observe? There are three axes are there, sir. One is all of you observe. This is going to be the breadth axis, and this one is going to be the length axis, and this is the height axis. Now these are the three lines, the three axes of the solid: length axis, breadth axis, height axis. Are you observe? This is breadth axis, this is height axis, axis for the height, and this is going to be the axis for the length. So depending upon, sir, once these three lines are there, they are going to appear like this. Are you observe now? So these three axes are going to be appears here. I was mentioned here. For example, now let us consider this is the height axis, this is the length axis, this is the breadth axis. Actually, if you observe, breadth, length, and height, these three are actually perpendicular to each other, but appears not perpendicular because it is vertical only. But this is appears as some inclination with the horizontal. This is also some other inclination with the horizontal. But the viewing angles will be changes. Therefore, I am going to consider them. The angle between L and H, I am assuming it as alpha. The angle between length and breadth, I am assuming it as beta. Angle between breadth and height, we are assuming it as gamma. So here, these are the three axes. Axonometric. What is meant by axonometric? Metric means measurements. Axono means axes measurement. Axonometric means axes measurement. Here, if it is a single object, I will consider the length. If it is a three or two lines are there, we have to consider the angle between them. Angle is going to be considered as the measurement. So here, three are there. Therefore, how many angles we are going to get? Three angles. The relation between alpha, beta, gamma. Based on these three, they are divided into different categories. What they are, sir? For your clarity, I am going to cut this particular part, and I will mention it is in another diagram. This part I am going to consider in another page. We will try to place it. So for your axonometric projection. So here, if you observe now, so here alpha, beta, gamma are there. If alpha is not, if all these three are having the different values, for example, one set I am giving alpha is equal to 140, beta is equal to 120, gamma is equal to 100. Why, sir? These three values only, the sum should be equal to 360, because alpha, beta plus gamma is equal to 360. Then it is called trimetric. Why it is called trimetric? Tri means three, metric means values or measurements. So three values are there: 140, 120, 100. Three values are there. That is why it is. Sir, only this combination, not necessary. 140, 115, no, 140, 110, sorry, 115, 105. So this is also another combination. Like this, how many combinations are? Infinite combinations will be there. So this is trimetric. These three values are different. Alpha is not equal to beta, beta is not equal to gamma. Then it is called trimetric projection. And what about the other one, sir? Dimetric. Di means two. Only two values are there. For example, alpha is equal to beta is equal to 130. Gamma is equal to 100. Then it is called trimetric, because 130 plus 130, 260 plus 100, automatically 360. So in this case, it is considered as dimetric projection. What about the third case, sir? That is most important, and most of the times we are going to familiar with this in engineering drawing. That is, if alpha is equal to beta is equal to gamma, there is only one option. That is 360 by 3 is 120. Then it is called isometric projection. Most important question. In isometric projection, the angle between the axes will be 120 degrees. But dimetric, trimetric, we can't able to say any combination is possible. That is why only isometric will be there in our syllabus. So that is isometric projection. Sir, what about another one, sir? That is, so if the object is changing its orientation, then it is called axonometric. Sir, once if observer is changing his orientation, then what it is called? Then what it is called? Then it is going to be considered as multi-view projection. Multi-view projection. So multi-view, what is meant by multi-view, sir? We are viewing an object in multiple directions. Multiple directions. In order to get the complete information of this object, we are viewing in different places. Once here, front, top, side, bottom, rear view, left side view, right side view, like this. So we are going to get this object by viewing in different directions. That's why it is called multi-view projection. Good, sir. Sir, again in multi-view projection, why it is first angle and third angle projection, sir? Why it is first angle and third angle projection? What is the major difference, sir? Here, first angle and third angle projections will be classified based on with respect to the relative position of object and principal plane. So here, let us consider observer is at infinity. Let us consider I am the observer. I am at infinity. And this is going to be the object. I am the observer. This is the object. If I am going to place the principal plane here, so if the object is in between principal plane and observer, then it is called first angle projection. Why it is first angle? Again, I will give in detail to you. Just you have to remember here it is. What is the first angle projection? When object is in between observer and principal plane, then it is called first angle projection. What about the third angle projection, sir? What is an example of it? Can you able to give the example of it? Yes. What it is? Whatever. Let us consider rays I am sending parallel, but in a cinema theater it is not parallel, but I am taking one particular example of it. Projector, film, and this is the principal plane, that is silver screen. Source of light, object is the negative, and this is the principal plane. In this case, it is a first angle projection. Okay. Now, So only the positions wise I am giving, but rays are different. Rays are diverging in cinema theater, but let us consider if they are parallel. That is the situation. Now what about the third one, third angle projection? What it is? So here let us consider I am the observer. This is the object. If I am going to place the principal plane here, all of you observe, this is the principal plane. If the principal plane is in between object and observer, then it is called third angle projection. Can you able to give the example of it? Yes, sir. Okay, first of all, I will write the statement, then I will give. When principal plane is in between observer and object, then it is called third angle projection. Then it is called third angle projection. I hope this is clear. Can you able to give the example of it, sir? Yes. If you go to the museums or jewelry exhibition, diamonds exhibition, they are going to keep it in a outside? No, sir. The gem is inside a glass box. So here what happened? So here glass box, each and every side is considered as a principal plane. I am the observer, object is inside, glass is here. So here this is considered as a principal plane. That is nothing but third angle projection. So if you observe, sir, let us consider in cinema theater, this is the projector, this is the negative, this principal plane is a glass. Can you able to get the shadow there? No, sir. It should be opaque in nature. It should not send the rays outside. It should be opaque in nature. In first angle projection, this point is also important. Principal plane should be opaque in nature, whereas in third angle projection, principal plane should be transparent. These are the points you have to remember in the entire classification of projection. So again I am going to place the entire classification of projection here. Just have a look into it. If you are aware with this particular sheet, you can able to answer the various characters of the classification of projection. It is one of the most important thing in the drawing. If you are not aware of it, just I hope you can able to get a much benefit from it. And if your friends are going to have try to share this particular video, they will also be benefited with this particular classification video. And in the next video I am going to give in depth of multi-view projection, one of the most important in engineering drawing. If you consider almost 3 units to 4 units, they are concentrated on multi-view projection. Last unit is a isometric, that to off, that is conversion of multi-view to isometric to multi-view. So it is off is there in axonometric, and few universities only they placed perspective projection in their syllabus. Majority I observed throughout the India, I observed so many universities because I delivered this particular class from Delhi to Kochi. So in majority of the universities they don't have the perspective projection. Even in my videos I will give that particular one also. So that is why multi-view projection is a most important one. I am explaining in detail about multi-view projection in the next video.